All right, so today we're doing notes over targets 12 and 13, our last two targets of this unit. And I really like these two targets for the end because they're a really good review of a lot of things that we've already covered in this unit. So on target 12, what we're going to do is I'm going to give you a graph, and then from that graph you are going to write the equation that represents that graph. So to start off with, just kind of thinking about what our answer should be. So two things. On A, the shape of the graph is that squiggle shape, which means your final answer should be a cubic, which means you should see an x to the third power in your equation. The other thing is if you think about your end behavior, notice how the left side is up and the right side is down, which means your leading coefficient should be negative. So when we think about standard form at the very end, our equation should start with a negative x to the third of some kind. So I always just like to think about that first before we get started. And again, it's just a great way to double check your work. Okay, so the first thing we're going to do is list our zeros. So remember the zeros are the x-intercepts, which we can just observe from the graph. So we have x equals 2, x equals -2, and x equals -1. And the order in which you do that does not matter. Just go ahead and list all three of them, or however many there are. Okay, so then notice that there is some room before we get to our factored form. So as of right now, we can actually write the majority of our factored form. So anytime you write the equation, you would have y equals. And I'm going to leave a space here, and I'm going to talk about that space in a second. But then we can actually write our factors based on our zeros. So if the zero is x equals +2, that means the factor is x minus 2. If the zero is x equals -2, that means the factor is x plus 2, and then we would have x plus 1. So I'm just taking those zeros and essentially switching the sign. But again, this isn't our complete factored form. We're actually missing something, which is why I left that blank in our factored form. So what I'm going to do is write what we have up here and showing some work here. But I'm also going to think about the fact that I gave you a point, an xy coordinate. And so what we're going to do is plug in the 6 for y and the 1 for the x. So thinking about that factored form that I wrote on the line, instead of writing y equals, I'm going to write 6 equals. And that blank, I'm going to use an a as a variable, and that's going to represent the leading coefficient, which again, just going back to what we talked about at the beginning of this problem, should be negative. And then I'm going to write the factors, but I'm going to plug in a 1 for all of the x's. So that would be 1 minus 2, 1 plus 2, and 1 plus 1. And now I'm just going to go through and I'm going to solve for a. So simplifying here, 1 minus 2 is -1, 1 plus 2 is 3, 1 plus 1 is 2. If I multiply -1 times 3 times 2, I get -6. So 6 equals -6a, and then if I divide both sides by -6, I get a equals -1. So going to our factored form, it's now completely finished if we put that -1 out in front, which should make sense again because our leading coefficient we talked about at the beginning should be negative. So in order to write your factored form, just to kind of recap so far, you need to find your zeros, and once you find your zeros, that's helpful because that gives you your factors if you switch the sign. And then the last thing you need to do for your factored form is you do have to solve for that a value by using the other point that I've given you in the problem. Okay, so now we have all this space, and ultimately we're getting to standard form. So standard form means everything is multiplied together, and there's lots of different ways you can do this. I'm going to go ahead and rewrite what we had in factored form. I'm not changing anything yet. Okay, so just some strategies when we go to multiply all of this out. First thing I like to do is just pick any two of your factors and go ahead and FOIL those together. So FOIL means you multiply first, outer, inner, last. So doing that, I would get x squared plus 2x, and then inner would be -2x, and then that would be -4. And notice I still left the -1 out in front and the x plus 1 at the end. So I'm going to clean up what's in those parentheses that I just multiplied, because if you notice, these two cancel each other out. So I'm just left with x squared minus 4. And now I'm going to have to continue multiplying. So our goal here is to get rid of all the parentheses. So I have to continue multiplying. I'm going to multiply those two together. That -1 stays out in front. And then this would be x to the third, which is a good thing because remember this was a cubic, so I want to see that x to the third. Then that would be plus 1x squared, and again I'm just foiling. And I don't see any terms that I can combine here. So the last thing I'm going to do to write my final answer is I'm just going to distribute that -1. Oh, goodness. So that would be a negative x to the third plus x, oh, that would be minus x squared if I distribute the -1 to everything, plus 4x plus 4. And then again, just going back to the original thing that we talked about at the beginning of this problem, is we talked about the leading coefficient should be negative since it was going downhill. We can see now it is. And it should be a cubic, so it should have x to the third, and it does. So all of that matches up. Okay, so we're going to do this same process, but now we're going to do this with a quartic. I know it's a quartic because it has that W shape. So just kind of starting with where I started last time, I know this is a quartic because I do know the shape of a quartic, which means I should see an x to the fourth at the end of this problem. And also notice that both ends are going down. This is a W opening downwards. So again, the leading coefficient should be negative. So when we get to that final line, that standard form, we should see a negative x to the fourth. All right, so getting there, we start off with our zeros. So our x-intercepts, anywhere it crosses the x-axis. Again, the order in which you write this doesn't matter. So I'm seeing x equals -1. X equals +1, x equals +2, and x equals +3. Now I'm going to start writing our factored form. And I said just start because I don't know what that a value is. So I have y equals, I'm going to leave a blank, and then the factors. And I'm writing the factors by switching the signs from the zeros. So x plus 1, x minus 1, x minus 2. I'm running out of real estate here, so I'm going to write it down here, and x minus 3. Now, in order to be able to find that a value, I'm going to have to use this other point on the graph, this x, y coordinate. I'm going to plug in a 6 for y. And remember, we put an a because we don't know what that leading coefficient is. You can call it anything, but a is usually what it's called. And then I'm going to replace all of the x's that I've just written with zeros. So that would be 0 plus 1, 0 minus 1, 0 minus 2, and 0 minus 3. Okay, so now I'm going to simplify all of those parentheses. So that would be a 1, a -1, a -2, and a -3. And now I'm going to multiply all those together. So if I multiply that together, that gives me -6, which means a is -1. Now a will not always be -1, it just happened to be both in these cases. But a -1 should again make sense here, just because we had the idea that it was a negative leading coefficient, so any negative number would have worked. If we got like a -52 for a, that would have also made sense based on what we know, just because we know the leading coefficient has to be some negative number. All right, so when you get to a quartic and you're multiplying out, which is our next step to go from factored form to standard form, it does take a little bit more work. Just because there are 4 factors instead of just 3 as we saw in the cubic. I mentioned at the beginning that this was a really good target for review. One of our targets earlier on in this unit was multiplying, and so it just really helps you with that, and just the whole idea that the zeros should match the factors and all of that good stuff. So like I did last time, I'm going to choose two factors to multiply together. So I'm going to leave that -1 out in front. I'm going to multiply together these first two, x plus 1 and x minus 1. So x squared, actually that would be, if I did outer, it would be minus 1x. And then inner, and then last. And I'm going to go ahead and multiply these last two factors together as well. So first, outer, inner, last. And then this next step, I'm not doing anything new, I'm just cleaning up what we had, because if you notice, those two cancel each other out, so we're just left with x squared minus 1. And then these two don't cancel each other out, but they do combine to get you a negative 5x. Okay, so our goal is to get rid of all of the parentheses here, so we still have some multiplying to do. I'm going to go ahead and multiply these two together. I can't use FOIL because it's not a binomial times a binomial. It's 2 times 3, so it's a binomial times a trinomial. So I'm going to start by distributing the x squared. So that would give me x to the 4th minus 5x to the 3rd plus 6x squared minus 1x squared. I'm distributing the -1 now. Plus 5x minus 6. And there are some things I can combine there. So I have x to the 4th, and then just minus 5x to the 3rd. And then the x squared terms, I have 5x squared plus 5x minus 6. And then the last thing that I have to do here is I have to distribute that -1 to everything, and then that will give me my final answer. I'm going to start writing it over here just so I have room. Y equals -x to the 4th plus 5x to the 3rd minus 5x squared minus 5x plus 6. And again, just kind of pausing here at the end to make sure our answer makes sense. We do have a negative leading coefficient, and we do have an x to the 4th to represent that quartic. So all looks good here. Okay, moving on to the last target of the unit, target 13. So this is basically the opposite of what we just did. So now I'm going to give you the equation, and you're going to come up with the graph. And so all the steps here are going to be given to you on your test as well. And it really just kind of walks you through the process of figuring out what your graph should look like. So at the very beginning, we give you an equation, and then we also give you one factor. So I want to think about this one factor. This factor actually also gives you a 0, and the 0 would be x equals -3. So what this information is telling you is that there's a 0 at -3, but also that there's an x-intercept at -3. So that's going to be helpful when we get to the graph. So I actually want to change something that it says here. It says other zeros. I want you to change that to all zeros. And the reason I think it's helpful to write all zeros is because if you look at the original problem, it's x to the 3rd power, which means there should be 3 zeros. And it just kind of gives you a nice little checklist. Once you filled in all of those blanks, then you know you found all the zeros. So one of the zeros was actually given to you. It's -3. So I'm going to go ahead and fill that one in. Now if you read the directions, it says find the other zeros using synthetic division and factoring. So I'm going to use synthetic division since I do know one of the zeros. So one of the zeros is -3. And then I'm going to use the coefficients from the problem. And then I'm going to go ahead and go through synthetic division. So I'm going to drop this leading coefficient, multiply, and again, this is a great target for review. And then I'm going to multiply again, add down, multiply again, add down, and this should make sense that your remainder is 0 because we already knew going into this problem that -3 was a 0. It gave us that information. Now, the reason we want to do synthetic division is that we want to get this to quadratic. So it started with a cubic, and remember synthetic division knocks off 1 degree. So this answer is actually 1x squared minus 2x minus 3. And the reason that that's so helpful is that we can factor a quadratic. So think about numbers that multiply to give you negative 3 and that add to give you negative 2. Those numbers would be negative 3 and 1, which means your factors are x minus 3 and x plus 1, which means your missing zeros are positive 3 and negative 1. So using that given zero and synthetic division and factoring, you're able to find all your zeros, which means you have your x-intercepts. So I'm going to go ahead and go down to the graph, and I'm going to graph these. So we have negative 3, negative 1, and positive 3. All right, so we're well on our way to create this graph. For your y-intercept, anytime you want to find your y-intercept, you plug in a 0 for x. And that goes back to, we've talked about that several times, especially first semester. So think about going back to this original equation, and if you plug in a 0 for x, 0 to the third power plus 0 squared minus 9 times 0 minus 9 is just going to give you negative 9. And you can test that with your calculator if you want to, but it's just going to be that last number in the equation. So 0, negative 9. And I go ahead and graph that. So notice as soon as I find a piece of information, I put it on the graph. All right, next thing it asks for is end behavior. So again, just a really good review. Remember when we write end behavior, and you are going to have to know this notation for your test, so make sure it's on your reference sheet. So end behavior, there's a right side and there's a left side. So let's look back at our original equation. So this was a cubic with a positive leading coefficient, which means this graph is going to be a squiggle up. So on the right side, the end is pointing upwards. On the left side, the end is pointing downwards. Now the reason that that's helpful for your graph is we know that on the right side, our arrow is going to be up. On the left side, our arrow is going to be down. And so that's just helpful when we go to connect the points to know where to start and end. All right, last thing we have to do, we're almost finished, is this is an XY chart if you want to think about it like that. It's kind of a horizontal XY chart. We're going to find the local max and mins. Another way to say this is we're finding the turning points. So when we go to graph, we have to know like where do we turn and start going the other direction in that squiggle shape. And we want those to be super exact. So the way we're going to do that is looking at our graph, you're going to pick the x values that fall right in between your x-intercepts. So for example, in between negative 3 and negative 1 is negative 2. That's going to be the first x value we'll choose. And then in between negative 1 and positive 3, the number right in the middle of those two is a positive 1. And so what we're going to do with that information is we're going to actually plug those in for the x values. So going back to your original equation, I'll start with a negative 2. I'm going to replace all the x's in the original equation with a negative 2. And I'm going to be careful to use parentheses, and this is something that you might want to go ahead and grab a calculator and do this with me just to make sure you get the same value that I do. And I'm getting out a positive 5. So make sure you also got out a positive 5. And then it's easy. Once you have the equation plugged into your calculator, just go back through and change those negative 2's to positive 1, which is our next number. So that's what I'm doing now. And I'm getting a negative 16. So these are the last 2 points that we're going to put on our graph. So negative 2, 5. Negative 2, 5 is right here. And then positive 1, negative 16. Positive 1, negative 16. Okay, so now you're going to use your knowledge as to what this graph should look like. It's a squiggle. We know it starts down here at this arrow. So I'm going to start down here. I'm going to hit this x-intercept, go up to your turning point, and that's where you turn. Then I hit an x-intercept, the y-intercept, go down here to the turning point, and then hit this last x-intercept and end going upwards. And I know that looks a little wonky, but we have all the points in the right place, and you can see that squiggle shape. You can see it's going uphill. So everything that we know about the equation should match what we are seeing in the graph as well. All right, so we're going to do this again, but we're going to do this with a quartic. And again, just a quartic because there's more going on. It just takes a little bit more time, a little bit more steps. And really the steps come into play in this first step. So taking a look at what was given. You're given this quartic, and then you're given two factors. And remember, the factors are designed to give you the zeros. So we know that x equals 5 and x equals 7 are both zeros. So looking at where it says other zeros, again, remember, I just changed that to all zeros. You don't have to do that if you don't want to, but I find it to be helpful because this is a quartic, which means there are 4 zeros. And so we already know 2 of them. We know 5 and 7 because that was given in the problem. So now what we're going to do is find the other zeros using synthetic division and factoring. So pick one of those numbers. I'm going to use 5 first, just going in order. Go ahead and set up your synthetic division with your coefficients from the problem. So that's 1x to the 4th minus 16, 86, negative 176, and 105. Okay, so going through the 1, that would be 5. If I add down, that's negative 11, which means this is negative 55. Really good review on synthetic division here. So that would be a 31. And then if I multiply that, I get 155. So then that would be a negative 21 if I add down, which would give me a negative 105 here. So when I add down, I get a 0, which is what I should get. Now, this actually isn't super helpful, this first synthetic division, because I started with a quartic, which means now I have a cubic. Cubic is not something that we can factor using that AC method that we did last time. So that's the reason I give you 2 zeros. It's because I want you to do synthetic division again. So use your second number, whichever one that is. In my case, it's a 7. And use your new cubic numbers. Make sure you use those new numbers. You can drop the remainder. You don't need to use that. And let's go ahead and go through synthetic division again. So that would be a negative 4. It's a negative 28. And this would be 21. So again, you get a remainder of 0. But the benefit of this is that now this is a quadratic. So remember, every time you do synthetic division, it knocks off a degree. So we started with degree 4 at the beginning. Then after our first synthetic division, it was a degree 3. And after our second synthetic division, it's a degree 2 quadratic. So I'm going to write the quadratic that we had left over here on the right-hand side. So that would be 1x squared minus 4x plus 3. So I'm going to find numbers that multiply to 3 and add to negative 4, just going through our factoring process. So those numbers would be negative 3 and negative 1, which means our factors are x minus 3 and x minus 1, which means our remaining zeros are positive 3 and positive 1. So we have some zeros. We have some x-intercepts, 1, 3, 5, and 7. So I'm going to go ahead and put those on the graph. Okay, so as soon as you find a piece of information, put it on your graph. Next step is to find the y-intercept. So remember, anytime you find the y-intercept, you plug in a 0 for x in your original equation. So going back to your original equation, if you replace all of these x's with 0, you would just get the last number, which is 105. So that doesn't seem super helpful because we don't have a 105 on our graph, but remember that is helpful. We talked about this first semester. because that means you shouldn't cross the y-axis when you connect your points. And so I'll kind of come back to that and tell you and remind you why that 105 number is helpful. End behavior. So starting with our notation, again, make sure this is on your reference sheet. This is what you would write every time you write your end behavior. Okay, and then let's think about the shape of this graph. So it's a quartic. It's a positive leading coefficient. So a quartic is a W. It's going to be a W opening upwards because it's a positive leading coefficient. So both ends are pointing upwards here. So the reason that's helpful for your graph is that we know both arrows are pointing up. So on the right-hand side, it's pointing up, and on the left-hand side. Now notice where I place that arrow. I placed it to the right of the y-axis because remember that the y-intercept is not until 105. So your graph should not cross or touch that y-axis. All right. Last thing that we have to do is we have to go ahead and find your local max and min, so your turning points. This time, because it's a degree for quartic, you're going to have 3 of them. And so let's take a look at what the x values are in between your 2 or your 4 x-intercept. So in between 1 and 3 is 2. In between 3 and 5 is 4. And in between 5 and 7 is 6. So that's how you pick the x values. And then to get the y values, you're going to plug those into the original equation and replace all your x's with that. So I'm going to start with 2. Going back up to the original equation, so 2 to the 4th, and again, you might want to practice this just because this is something that sometimes I see people make mistakes on. So I'm just replacing all of those x's with a 2 squared. Okay, so when I replace all of the x's with a 2, I get a negative 15. And then it's easier for the 4 because now I can go back and just change all of those 2's to 4's. So I'm going to take a second and do that. And I'm getting out 9. And now I'm going to replace all those 4's with 6's. So once you get it down on the first number, it's much easier for the next 2. And I'm getting negative 15 again. So now I have 3 points to plot. So I have 2, negative 15. I have 4, 9. And I have 6, negative 15. Okay, so this looks kind of crazy. It looks like a scatter plot from back in the day when you did scatter plots in Algebra 1. But remember what this shape should be. It should be a W, and it starts at the top. So just start kind of piecing this together. Hit your x-intercept, come down to your turning point. X-intercept, turning point. X-intercept, turning point. X-intercept, and pointing upwards. So you should be able to see that W shape. Okay, so this is a really good review of a lot of things we did this unit. If you can do this target, these 2 targets, then you are really in a good place for your test coming up.